Alright, so got the last section in chapter 7 where we're going to write and apply exponential and power functions. These first examples here, they want us to write an exponential function in the general term of y equals ab to the x power given the following points. So for example A, we know that our exponential function using this equation lands at the 2 points 1 comma 2 and 3 comma 50. So what we're going to do first is we're going to make two equations. We're going to use the y equals a b to the x power, and what we're going to do is substitute in the values of the points in for x and y and try to solve for a and b. So let's do that. Let's write two equations. So I'm going to write in 2, which is my y, equals a times b to the x power, and that happens to be 1. Second equation, I'm going to write 50 equals a times b, and then that's going to be to the third power. So what this is kind of like, this is very similar to like using the substitution methods in like systems with linear equations when we learned in intermediate algebra. What we're going to do here is I want to solve for a in that first equation. So if I solve for a, I'm going to divide both equations by b, which gives me a equals 2 divided by b. So from here, I'm going to substitute in this 2 over b into that second equation. So now this equation here is 50 equals, instead of it being a, it's going to be 2 divided by b times b cubed. So if I combine these, this becomes 50 equals 2b cubed divided by b. I use my exponents rule with same base. So here 50 equals 2b squared. And dividing both sides by 2, I get 25 equals b squared. And b ends up in equaling 5. Now we only take the positive root when we square root when it comes for finding exponential functions. So what we've done is we found the value for b. Now what we can do is substitute back into the equations to find what a is. So I got b here, so I'm going to say a equals 2 over 5. So I got b, I got a. I have the things now to write my general equation. So the general equation means that x and y are again variables. So now I have y equals 2 over 5 times 5 to the x power. And that is the equation that we're looking for, and that's the answer I want. For example B, we're going to do the exact same thing, except we just have different points. We got 3 comma 1 and 5 comma 4. So let's write these out. So the first one's going to be 1 equals a times b to the third power, and the second one's going to be 4 equals a times b to the fifth power. So in this first equation, I'm going to solve for a. So solving for a gives me a equals 1 divided by b cubed. I substitute back into the second equation, so it becomes 4 equals 1 divided by b cubed multiplied by b to the fifth. And then combine those, this equals b to the fifth divided by b cubed. 4 using the quotient property, this is b squared because I subtract my exponents, and then taking the square root, b ends up equaling 2. So now that I know that that's 2, I can substitute it back into the original equation. So what I can do is I can just substitute it back in here, and I know that my a will equal 1 over b cubed, which happens to be 8. So I know that my a is 1/8, my b is 2. I've found those values to write my equation. So my equation here for this is y equals 1 over 8 times 2 to the x power. These last examples, they want you to be able to write a power function where we have the general equation y equals ax to the b power, and then we're going to be given the following points. Use the same strategy for to start with that we did with the first examples up there. I'm going to use those value points to write two equations. So I have these two equations. I'm going to write it as 3 equals a times 2 to the b power. And then the second one's going to be 12 equals a times 6 to the b power. From here, I'm going to solve for a. So this, if I divided 2 to the b power by both sides, I get a equals 3 over 2b. I substitute that into my second equation, so now I'm left with 12 equals 3 over 2b, or I'm sorry, that's wrong. Let me erase that. This one is 2 to the b power, I apologize, all multiplied by 6 to the b power. And I have, these are like terms here, so 3 to the b power divided by 2 to the b power ends up making this 12 equals 3 times, this would be 3 to the b power. Dividing both sides by 3. So that gives me 4 equals 3 to the b power. So now to solve for b, I must take the logarithm. So now this becomes log base 3 of 4 equals b. So from here I can use the change of base formula. So this is log of 4 divided by the log of 3, which equals b. And punching that into my calculator, b will equal roughly 1.26. So I found what b equals. So if I plug it back, let's say I plug it back into this equation here as b equals 1.26, so I would have something like 2 to the 1.26 power. So it would be 3 divided by 2 to the 1.26 power. So that would give me something like, my a would end up equaling something roughly 1.25. And that means I've figured out what my a is and what my b is. So now I can go back to my general formula here and put in values for a and b. So then this is equals y equals 1.25 x to the 1.26 power. So that's the equation we're looking for. Same thing goes for b, and again, these are approximations, so as long as you're close in these decimals, that's what I'm looking for when we're writing these equations. But we're going to do the exact same thing in b. So I'm going to rewrite this as 8 equals a to the 4 to the b power, and this one becomes 30 equals a to the 8 to the b power. I'm going to solve for a to this one, so this becomes a equals 8 over 4 to the b power. I substitute the a's in, so this becomes 30 equals 8 to the 4 to the b power multiplied by 8 to the b power. I have the same exponents here, so I can actually divide those out. So this becomes 30 equals 8 times, that'd be what, 2b? So I can divide both sides by 30, so that becomes 3.75 equals 2b. I can rewrite this as a logarithm, so I can say log of 2 of 3.75 equals b. I can use the change of base formula, so I can say log 3.75 divided by log of 2 equals b. By punching that in my calculator, I get b equals 1.91. So by punching that in my calculator here, I get b. I'll plug it back into this one, so I have 4, instead of being b, it would be 4 to the 1.91 power. So then I have 8 divided by 4 to the 1.91 power, and that gives me something roughly for A, something along the lines of like 0.57 about. So when I rewrite this as my equation, I can rewrite this as y equals 0.57 x, all of which to the 1.9 power. Again, these are approximations. As long as you're close, that's what I'm looking for. And that is being able to apply exponential and power functions. Hope this helps. Until next time.